Algebra 2 notes, 5.2 polynomials, linear factors, and zeros. What is the factored form of each polynomial? Think back to chapter 4. We did a bunch of factoring. Most of our factoring was with a quadratic trinomial, so x squared and 3 terms. But this one, it has a cubic trinomial. So what you first want to do is pull out that x. So remember, if I take an x out of all those, what do I have left? So what you're thinking is, if I take an x out of each of these, what is the leftover? So we're left with x squared minus 2x minus 15. From there, we can factor further. So think multiply to be 15, have a difference of -2. Since our lead coefficient is 1, there, 1x squared, these are the easy ones to factor. So what multiplies to be 15? So we have 1 and 15, or 3 and 5. So which pair had a difference of 2? It's got to be the 3 and 5. And then remember, we want it to be a -2. So if I have 5x and 3x, I need the 5x to be the negative. Okay, now when you write out the factors, don't forget to rewrite that x that we pulled out front, because that also is one of the factors. All right, go ahead and try B. Again, this is similar to this first one. First, take that x out, and then once you have that rewritten, try to factor it further. All right, so if I take an x out of all these, I'm left with x squared minus x minus 12. So now factor this further. Again, lead coefficient is 1. See if you can finish that up. All right, multiply to be 12 would be 4 and 3. Bigger one's got to be the negative. So our factors are x times x minus 4 times x plus 3. Okay, now example 2, we're going to take these a step further. What are the zeros of each polynomial? So we're going to set that equation equal to 0. Remember, the zeros are the x-intercepts or solutions. You'll hear a bunch of different words that you can figure out by doing the same thing. Solutions, zeros, roots, x-intercepts. Those all mean set it equal to 0 and find the answers. All right, so if we set each of these equal to 0, our answers are -2, 1, and 3. And then let's go ahead and sketch this one out as well. So our zeros were at 3, 1, and -2. So when we do this assignment, I'm not going to give you graph paper, but I do want you to write out what the x values are. So I wanted you to see where these cross. You don't need to worry about being accurate on the y values. All right, now, since all of these have a 1 in front of them, if I would multiply this all out, I'd get a big equation that said y equals x cubed, and then a whole bunch more stuff. Because 1x times 1x times 1x, that's how you can get that original lead coefficient, 1x squared. So what we were doing yesterday, we figured out that that was a positive odd function, which meant that it's down and up. Okay, so I know that it's going to end up going up. Now, every time we have a 0, we're going to go through the x-axis. So here's where I want your x's accurate, but your y's don't have to be perfect. I'm not going to ask you to plug in 2 and see where this y value is. If you want to do that to have a more accurate graph, you can, but you can just make it go through the zeros. Okay, and now look, did we have a down and up graph? Yep, down and up. All right, go ahead and work on B by setting those all equal to 0. Don't forget about setting x equal to 0 as well. Okay, go ahead and try to graph that out. Now, if I would have multiplied this whole equation out, it would have looked something like that. So again, the lead coefficient is a positive, and it's an odd function. So it's kind of like the one we just did. We know that it's going to be down and up. All right, I'll give you about 15 more seconds to graph it. So your zeros are at 3. Don't forget about the 0 and -5. Since it was supposed to go down and up, I know it's going to go in going up. Always if it's a positive, it's going to end going up, even if it's a parabola. And then I'm going to make it go through the x-axis. And it's going to go back up. And then finally hit that last 0. And again, this would be a down and up. All right, next, factor theorem. The expression x minus a is a factor of the polynomial if and only if the value of a is a 0. All right, so this one, example 3, is very similar to example 2. It's just opposite. So it is giving us the answers, saying here are your zeros. We need to figure out the equation. So according to this theorem, we can write it x minus a, where a is my 0. So I could write it x minus -2. Well, that's just going to change to the factor x plus 2. So if you go back and think about how we figured out the answer on example 2, we had x plus 2, but then we set equal to 0, so it ended up being x equals -2. So if that 0 is -2, my factor is x plus 2. If my 0 is 2, my factor is x minus 2. What would this third one be? Would it be x plus 3, or would it be x minus 3? All right, so what we're going to do is multiply the 3 factors together. So that third factor should have been x minus 3, because it was positive, so do the opposite. All right, so we can FOIL the first 2 out. So first, outside, inside, last, we get x squared, outside minus 2x, inside plus 2x, and last minus 4. We haven't messed with that third factor yet. Okay, notice the minus 2x and plus 2x can cancel. And now we've got 2 binomials again, so just do it again. So we've got first, outside, inside, and last. And now we wrote the big equation. All right, example 4 would just be another example like this, but with 4 zeros. So then just take 2 at a time, multiply them, and so on. Okay, and then example 5 is like one we already did too. So we're just going to jump to the back of the worksheet. multiplicity of a root. So why don't you guys take a minute to read through this and go ahead and pause the video. All right, so if that factor is repeated an even amount of times, so like x minus 2 to the second or x minus 2 to the sixth, what's going to happen at those points, 2, so it'd be positive 2, is instead of going through the x-axis, it's just going to touch the x-axis. Okay, but if it has an odd multiplicity, we're just going to do it the same way we've been doing it. So if it's x minus 1 to the first, or x minus 1 to the seventh, we have a 0 at 1, and it's still just going to go through the x-axis. All right, so first thing, just set these equal to 0, as we've been doing. Now, since we have a repeated root, we don't need to write it twice. We can just set one of them equal to 0. So we say x equals 4 with multiplicity of, and then look at the exponent. That's where we get our multiplicity number. Multiplicity of 2. So since that number is even at 4, instead of going through the x-axis, it's just going to turn back around. Okay, now if you think about what this graph looks like, this is that parabola move forward to the right. So my graph's not perfect, but it's a good idea of what it looks like. All right, let's look at the next one. So again, just set them equal to 0. So our first 0 was negative 3 with multiplicity of 3. Second 0 would be 2 with multiplicity of 3. Since these are both odd, that tells me the graph is going to go through at those points. So we have a 0 at negative 3 and a 0 at 2. It's just going to go through the axis. There you go. Now, this might not be exactly what the graph looks like. It might have something else like going on right here, you know, and maybe over here since it was to the third power. But as long as we can get the general idea of where it's crossing the x-axis, that's good. All right. Don't forget that if you have a number in front of x, when you set it equal to 0, your answer is not just negative 3. We have to subtract the 3 and divide by 2. Okay, so it's negative 1.5. And then the 1 had a multiplicity of 2. So that means that 1, that's the one where it's just going to touch the axis, turn back around. This one had that second one was just to the first power. If it's not listed, or that first one. So it's going to go through at negative 1.5. Okay, D isn't done yet, so we need to factor it completely. So we can take an x out. So we're left with 2x squared plus x minus 1. We can factor it further. Again, don't drop off that x. Leave that in front. Plus minus. So our zeros are 0, 1/2, and negative 1. None of these have multiplicities because they were all to the first power. So don't look at the original equation, look at the factored form. All right, so go ahead and try to see what that graph would look like. So all of them had an odd multiplicity, so it's just going to go through each of those points. All right, so your assignment, 5.2, page 293, numbers 8 through 14 evens, 15 through 20, 28 through 34 evens.